right? So let's say the question is, what is the area under the curve bounded by x equals 1 and x equals 5? In other words, I want this area here. Now, we learned in the last class that you can approximate it by a bunch of rectangles, right? Just the area of a rectangle. But even better would be a trapezoid that's on its side. If I wanted one trapezoid, it would be from this point here. I would draw a line there. This is a trapezoid on its side. And the area of a trapezoid is this. It's 1/2 h. H is this value here, the height. They should call it the tilted trapezoid rule. There's my trapezoid. Okay. H. We're going to call this y1, y2. Doesn't matter what the slope is. It's just y1, y2, h. So it's going to be the area is 1/2 h, y1 plus y2. So if I wanted to figure out this area here, I would need the value of h here and the value of h here. And so, but what you can see is you're going to get an area under this curve that's too big, right? Because this part doesn't belong. But what if I make it into two trapezoids? Let's say I take it right in the, I break up this area that I'm interested in into two trapezoids. And you can see I'm going to get a better approximation, but there's still some problems. Right here, I'll have trapezoid 1. And then trapezoid 2. So it's still good, but it's not perfect. Now you can see where I'm going with this. What if you divide it into an infinite number of trapezoids? Well, that's what the integral does. So the formula for the trapezoidal rule is this. So the confusing part when you first do this is you have to remember to times intermediate values by 2. You can see that this value here, the intermediate value, is part of two trapezoids. It's part of the first trapezoid, and it's also part of the second trapezoid. The only ones that aren't multiplied by 2 are the terminal values because they're only part of one trapezoid each. That's kind of the rationale there. What is the area under this curve with one trapezoid? N is the number of trapezoids. Let's compare n equals 1 to n equals 3 or 2 to n equals 4. Be A equals, so what's H? Well, H is always defined as the change in X. In other words, over the number of trapezoids. So in our first case, it's 5. I'm interested in 5 to 1. And then how many trapezoids? 1. So my H value is 4. So to figure this out, I go 4 over 2 because that's my H value. So this is going to be, remember, one trapezoid. What is X at the first value? Well, X at the first value is 1, right? So 1 over 1. Now, if there's one trapezoid, there's just the first one and the last one. There's no intermediate values here. So then plus 1 over 5. Six over 5, so 12 over 5. So that's the approximate. So this is going to be bigger than the actual area under the curve because again, you can see from the graph that there's just a lot of, I overestimate. Anything that's concave up is going to be overestimated. So let's try two trapezoids. Let's see if the numbers should get smaller now because right now I'm going to do the blues. Right, in my blue situation, I have this trapezoid and then also this trapezoid. So what is my H value for delta x over n with 2? It's going to be 5 minus 1 over 2. So in other words, my intermediate value here 2. So the distance here is 2, so this is 3. If to create equal trapezoids of height 2, that would work. Okay, so how do I do that? Area of 2 trapezoids is the h value. H value is 2. So again, this just takes a little bit of practice. Yeah, you just have to do like a couple of them yourself, and then you'll see it makes a lot more sense. 2 over 2. And then what's my first value? Well, it's the same for all of them, right? Because it's just the first value is just 1. The x naught value is still the lowest boundary, so it's still going to be 1 over 1. Okay, now what's my second value? My second value is 3. 1 over 3. And then my last value is still the same. 1 plus 2 divided by 3 was 1 divided by 5. Okay, so here I have 1.89 approximately, right? 1.89. What was this thing? So 2.4. So that's quite a large overestimation. But let's do it with 6 just to see if it's how accurate it is. So if I want 6 trapezoids, that means that my h value is 2/3. So you can see how it's a little annoying when you have a lot of trapezoids, and especially when you don't have a nice H number. If you have a nice H number, then it makes all the difference. But I'm just going to power through here because we're almost done now. Okay, 1.64. So 1.64, let's say approximately. So again, smaller and smaller and smaller. The integral of 1 over x dx from 5 to 1 should be given by ln 5 minus ln 1. So 1.61. So that's pretty close.